Yeah, camera dude now.
I don't know.
No.
Yeah, the front row should be like the exit seat
I
on the
forget
plane.
about my own phone.
Be a little interview you have to pass. All right. Okay, so that's not too bad, right? So 82 is feasible. A little feasibility study. What about part C? Just conceptually, before you do anything, would the 90% confidence interval be smaller or larger than the 93%?
Smaller.
Why would it be smaller?
Because it's 90.
Smaller than 93.
Because for 93, I want to catch 93%. If I only want to catch 90%, my net can get smaller. Exactly, I love it. I love it. It's just that I don't often get that answer correct that quickly from class. So does that make sense to everybody?
Well, what do you want us to write?
For that answer, yes. Smaller, right? Would it be smaller or larger?
It would be smaller.
It would be smaller. That's all you say. And then why? Why would it be smaller?
Because 90
I got to catch
98.
less stuff, so I don't have to go out as far. That's period. That's the actual concept behind it. I don't have to catch as much data, so I don't have to go out as far. Is my z-score going to be bigger or smaller than 1.81?
Smaller.
The z-score controls how far out you go. If I want to go less out, my z-score is going to be smaller. What's the z-score for 90%? It's on the little baby chart. And if you didn't see it earlier, little baby chart. It's way down in the corner. Here's your positive z-score chart. I'm going to get this in here. Way down in the corner. Way down there. 0.90. This is what we did earlier, right? 1.645. So to do this work, it's relatively quick. We've already done the work. We just have to put the right number in now. So I do all the same work, except instead of using 8.1, I just use 1.645.
Wait, I'm sorry, what?
So again, so if I want to find the 90% confidence interval for the mean,
Oh, sorry.
the z-score is 1.645 to capture that much. It's not as far out as 1.81, so I don't catch 3% more. I just want to catch 90%. So that's why the z-score is smaller, so I don't go out as far. How far out do you think you have to be 100% confident?
All the way.
And all the way would be negative infinity to infinity. And that's just to trump any question. Like a student asked me before, why don't we just make it 100% and just be sure about shit? Well, then you'd be like, well, the percentage of the number of people going to come are between negative infinity and infinity. Thanks for that. It's going to help me plan. We could need anywhere from negative chips to infinite chips. I don't know what to do. All right, do you sell infinite number Joe? Hello? All right, but does that make sense? That's why we have to kind of, it's a trade-off. If I go further and further out, there's a type of mistake I can make more often. So if I don't go far enough out, then I might not catch the real mean. But if I go too far out, then my interval becomes maybe not so useful anymore. So that's why 95% is kind of like a nice balance between those two ideas. And so I want to show you real quick, if you remember, I've shown you Gallup.com before. Change. No. Change. Try again. There it is. It did change. I want this. All right. Just forgot what I wanted. So here's a little story about what Americans worry about most. Got a beastie voice on. Let's see, blah, blah, blah. So they worry most about hacking. So, of course, it makes sense. If you're going to do a lot of shopping, you're worried about what's the next store that's going to put out the story about, guess what? They got the cards again. So is everybody kind of with me? So 69% frequently or occasionally worry about their credit card information being stolen. The 31% are just people that just never leave the house, I guess. Only 7% are worried about being assaulted or killed by a coworker. That's kind of encouraging. You don't want that to get too high, or else something's wrong. Now, all of these, they state this. I love the way Gallup does this. It's very direct. They say 69%, but is that the true percentage?
No.
No, that's the percentage they got from
The sample.
And if you get a percentage from anybody, any source, magazine, online, this thing called a newspaper. If you get any percentage or any data from something that doesn't tell you where it came from, you can't trust it worth shit. You always look up the source if they don't tell you. So if you look way at the bottom of any Gallup stuff, and I showed you this once before, but now it's going to make a lot more sense. Results are based on telephone interviews conducted blah, 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 with a random sample of that many adults. See, I told you, it's always about 1,000, believe it or not. Adults, blah, blah, blah. The margin of sampling error, the error, is plus or minus 4 percentage points at the 95% confidence level. So now that totally makes sense to us. We completely understand what that means. Or you should, if you were here today, which all of you were. Okay. Blah, 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 blah. They go on a little bit about how they have to talk about the phoning issue. That's an issue that we know. Okay. Cell phone respondents and landline respondents. All right. Well, they even go, you won't go too crazy here. Let's take it too long for it.
Was that a voluntary response?
Yeah, when they call, you can certainly say, I don't want to be a part of this. So there's a whole class, it's beyond stats 2, where you talk about survey methods and ways of handling things like the possibility somebody's lying to you, what to do if you have a large number of people that decline to be a part of the survey, things like that. So you actually have ways to take that into account. So you don't automatically discount every survey ever done just because you go, people could lie. You got ways that you can kind of double check that. Not everybody's going to lie, but some people will. And you have ways to kind of internally check that out. Did that load? No. So you're not going to see whatever that is.
It did.
It downloaded.
Downloaded.
Oh, it downloaded. Here it is. Holy shlomo. So if you really, really want to see the backstory, there. Have fun with that. All right, how are we doing? That's why I love Gallup. It's so beautiful for our teaching. And I just love it because not very many sources get that in depth the way you should. So often you see stupid little percentages and stuff, and where the hell that come from? Their own poll. Well, then who looks at you? You're only talking about those people. You're not talking about anybody else. Okay. So the last piece on here, this is the last thing we're going to do today. We're going to figure out where the hell this thing comes from. And the reason I want to show you the Gallup poll is, it was all about percentages, right? It said plus or minus 4 percentage points. It was all about P. And you see Q up there. So you see very familiar things up here, right? Which kind of makes sense because that should sort of sound like a binomial. Exactly. So for each one of those questions, they can either be worried or not be worried. Okay, cool. Blah, 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 blah. Oh, that's me. Straighten the wall out. All right, so let me see. So for a binomial situation, what is mu?
The average.
NP.
Oh, yeah.
Really? And what's sigma? Square root of NPQ. Cool. Now, do you notice something about that equation? What's a little weird with our variables?
It has a little hat on them.
I love it. It's got a little hat on it, right? The P and the Q have little hats. P hat doesn't sound like something you should wear. But sounds like when we used to go fishing, we'd have a jug, and yeah, I've had if you need. But this is for a population, of course, right?
Yeah.
So when you see P without any clothes, without any hat, that's a population proportion. When I say that 5 times.
Population.
If I want to know the corresponding X bar, that's kind of like the sample mean, I want the sample percentage, which we designate, of course, by putting a hat on. Right? So X bar would equal NP hat. So all P hat means, much like mu and X bar, P and P hat are exactly the same idea. P is for population, P hat, Q hat for a sample.
Sample proportion?
Sample proportion or sample percentage. Right? Those words mean the same thing. Cool. So of course sigma would be square root of N
P hat.
P hat
Q.
Q hat. Yes, there's no hats on almost everything. How we doing? It's just a choice of symbol. I wasn't there when they chose the little hat. I don't know what was happening that day, what they were drinking, what was happening, but they chose to put a little hat on it. Okay. How we know so far? So if I want to do something sort of like mean plus or minus z standard deviation, I'm writing that way for a reason, because I don't want us to make this mistake. Only one person, one or two people, I don't want to make the one person feel better. One or two people on the binomial problem, yeah, there was about a couple of people, divided the standard deviation by the square root of n. You don't do that for a binomial problem, because I'm not talking about the sample means in that problem. Right? So most of us, so you really pretty much only do one tweak at a time for that kind of problem. So here, if I wanted to set this up, the standard deviation is this, right? I don't divide by square root of n, because that's not this kind of problem. Of course, the mean is,
X bar.
let me say that, sample mean, yeah, x bar, which is otherwise known as
NP hat.
np hat. And this would approximate where np is. What was np again? Mean of the
Population.
population. I love it. So we're being a little more precise here with how we talk about this. Mean of the population, and this is the mean of the sample, because it's got a little hat on. How are we doing so far? So what we did before was the mean was kind of approximated or caught by x bar plus or minus z sigma over square root of n, right? The formula we were just using several times. So that's the kind of idea I'm trying to capture here. But I don't want to talk about means. I want to talk about the percentages directly. Right? I want to know 68% plus or minus 3%. I want to know percentages, not n times p. So how do I get rid of the n? Divide by. So if I divide by n, okay, I'll do this. The population proportion.
Why are we getting rid of n?
I want to be able to have a confidence interval that says something like somewhere between 75.3 to 91.7% of my students will pass, or something, right? I want to be able to have a statement dealing directly with percentages. Currently, is that a percentage?
Oh, so
No, it's actually a mean. It's actually a number of people or something, right? So I want to divide the n out of there, so I talk just about the percentages. Now, technically, there's nothing wrong with this equation at all. You can just deal with this equation, but we want to use, and in fact, you see this all the time when they talk about the elections coming up. So if anybody's paying any attention, at some point they have polls that say 42% are going to vote for Kashkarian. I love that name. It's just, and 45% are going to vote for the other person. And but at the very bottom, you always see plus or minus 4%. So I want to be able to talk about the percentages themselves directly. So I want to get rid of n. So that's pretty obvious that I can just kill those n's. I can kill those n's. But what the hell happens here? Can I kill those n's?
No.
Why not? Yeah, you can't divide unless they have the same root. Today is the heaviest day in algebra yet. So how do I make them have the same root?
You multiply by their reciprocal.
N is the square root of what?
N squared.
N squared. I love it. And that's such a weird question. I'm glad you either see what I'm trying to say or you don't. You're like, I don't know what n is the square root of. Y. N is the square root of yellow. So I can replace n with the square root of n squared, and I haven't changed a damn thing, right? Mm-hmm. And a major reason that is because n itself is positive. If you see why that's important. So I can totally replace n with square root of n squared. Of course they're the same. What's the square root of n squared? N. The square cancel, right? So that is like, I just didn't do a damn thing. You're like, good job, Jeff. You changed nothing. But now that since they both have the square root, what can I do?
You can X them out.
I can't X them out. How many n's cancel? One.
You can divide.
And there's one left down there. So here's the equation fully. Jeff, get out of there. Plus or minus z. You're not letting it look like the zth root. That would be really weird. P hat, Q hat, over n. So that is where that equation, if you look at the handout I gave you, that's the equation that's sitting there staring in your face, right? There it is. That's where it comes from. So it's not because you divide by square root of n to do so. You can kind of remember it that way. Both equations are in some way or another divided by n, right? But you can see this is a very different reason why it came out like that. So the weird thing about these problems is it feels like you're never given enough information because you don't really have to be told much at all. So let me give you an example. We ask 482 people who they will vote for governor in California. Let's see, what do you want to say? I want to say 209 say Cash Carey, however you say his name. We'll call him Cash. All right. And the other, whatever, say Brown. How are we doing so far? Does this make sense so far? I asked 489 people, who are you going to vote for? 280, what did I say? 209 people say they're going to vote for Cash Carey. If you never heard this word before, I'm a little worried. Jerry Brown, you should know that name. Right. Find the, let me be nice, 99% confidence interval for a true percentage who will vote for Cash Carey. Now, to be honest, real quick, just to make sure you guys understand why this is binomial, very often you have people say they'll vote for Cash Carey, or they'll vote for Brown, or they are undecided. Right? So you might go, it's not binomial, it's 3. No, it's in each case, Kashkarian or not, Brown or not, undecided or not. So each of those 3 cases are binomial in nature. Because right now, what's my P going to be all about? It's all about the percentage you're going to vote for Kashkarian. So what's Q going to be?
People are going to vote for
People
Brown.
who ate, who didn't say they would. So that includes the undecided and the Brown people, right? Okay, good, you good. So how do I make P hat?
482. No.
How do you get a percentage from a group you've talked to?
And P.
How many out of how many said they're going to vote for him?
482.
209 out of...
482.
Please, dear God, if you get a number bigger than 1 here, something went very wrong. Q's going to be negative then. It's a little freaky. All right? Can't be bigger than 1. Just trying to tell you, hey. So always take P hat and Q hat out at least 3 places.
434.
Yes, 434.
Yeah, 0.434. So what's Q hat? 1 minus that, what?
0.566.
Beautiful. I like it. And then to find the 99% confidence interval, I actually got everything I need. It feels like I got less because I don't need as much. Once I got P hat, I got Q hat. To get any of that, I had to know N. So I've already got N. What's the Z-score for 99% if you look at your little baby chart there at the corner?
2.575.
Beautiful. So then it would just be plug and chug again. P hat plus or minus, so 0.434, give or take. This many. Standard deviation, square root of P hat times Q hat. Got it. Divided by N, which was 482. For some reason, our people put 209 there. But N's always got to be the total number. I don't know if you remember, but 209 is actually X, the number of successes. So if you want a formula for P hat, it's X over N. Successes divided by the total. So then you just throw that in the calculator. Be a little careful here. You've got to stay in the square root until the end. So if you have a newer calculator, the square root actually just grows over everything. The older calculator, you got to, don't close that parenthesis until the 482. Right? Get the error, then add it, subtract it. I'm rushing a little bit because it's got to be somewhere at 5:30. I didn't realize it was that late already. So in the meantime, we'll do this one first next time. And then you could imagine that there's a very similar N equation if you do the same thing, set the air equal to this and solve for n, you get its own little n equation. Okay. That's plenty.